The last thing we're going to talk about is distinguishing between correlation and causation. Oh wait, oops. Let me go back. Sorry. Okay, so we've talked about looking at a graph and finding correlation. The next part I want to be able to talk about is looking at a description and seeing if there's a positive or negative correlation. So let's take a look at these three examples. I see number one, height versus the weight of 100 male African elephants. So in my brain, I'm thinking, okay, as the height increases, does the weight increase? I'm going to assume it's likely positive, right? That kind of makes sense. As an elephant is taller, they probably weigh more. When people are taller, they probably weigh more. So it's likely a positive correlation. The next one says distance driven versus the gas used. So this is saying that as I drive, my gas probably decreases because the more I drive, I run out of gas. So this is likely negative. Okay. Number three, the amount of time spent studying versus the GPA. So this is saying the more time I spend studying, the higher my GPA will be. I'm going to say this is likely positive. We've looked at a lot of data of students who study and do homework, and we've seen that they get better grades. So that's likely a positive correlation or causation. We call this causation when one variable causes the other. The other one says hair length versus height. So this is saying as your hair length gets longer, that height gets height gets taller or height gets shorter. This to me says no correlation. Having long hair has nothing to do with height, right? You can be a tall person have long hair, short person having no hair. So I'm going to say this is none, right? There's no correlation. And number five, this says distance walked in a pair of shoes versus the thickness of the sole. Well, I don't know about you, but when I use a pair of shoes more and more and more, that sole gets smaller and smaller. The shoe wears down. So that is a negative correlation. As one goes up, the other goes down. Okay, so that's being able to look at a description and determine correlation, causation. Okay. The last thing we need to talk about is, and it's kind of very similar to what we just did, but distinguishing between something being correlated and that correlation causing the other. So we just did a little practice of that, but let's take a look at some other examples, okay? So this says first read the description of the experiments and identify the two variables, and then describe whether that variable is likely, doubtful, or unclear to be causing a change in the other. So the first example says the manager of an ice cream shop studies its monthly sales and notices a positive correlation between the average air temperature and how much ice cream they sell on any given day. So my first variable is ice cream, and my second variable is temperatures. And this is saying that do the temperatures cause more people to buy ice cream? I'm going to say that this is definitely likely. It is likely that higher temperatures cause the ice cream sales. When it's hotter outside, people get ice cream. When it's colder outside, people don't want ice cream. So temperatures, I think, absolutely cause ice cream sales to go up. Okay. Number two, there's a negative correlation between pirates and divorce rates. As the number of pirates has decreased over the years, divorce rate has gone up. Now, while this may be true, we might be seeing pirates decreasing over the years, and we are seeing divorce rates go up. Is one of those things causing the other? And I'm gonna say no here. It's just a coincidence that this has happened. It's not like the pirates are going around to married people and making them get divorced, right? So this has no correlation, even though they have a trend, right? Even though this is negatively correlated, so this is a negative correlation. Really, it has no causation, right? There's none. The cause is not true, okay? And the last one says there's a positive correlation between fire trucks and fires. So as the number of fire trucks are being purchased at fire stations, the number of fires are going up. So I think there's two things going on here. It could be that as fire trucks increase, there are more fires in the area. That's what that's saying, like, right? If there's more fires, we need more fire trucks. Now, I don't know what's causing the fires. I don't think the fires are being caused. Are fires being caused by more fire trucks? And I'm going to have to say no here. Like, it's not like when a fire station purchases another truck, suddenly 4 more houses are going to catch on fire. So this definitely has there's no causation here. Even though it's positive, even though it happens that more fires are happening because there's more trucks, it's definitely not causing it to happen. Okay, so this is a really important thing to think about in stats when we look at scatter plots and trends. Okay, so that's it for this. It's your last video, so well done, everyone. The practice here is a little bit challenging because you've got some weird questions that I haven't shown you in the video, but you should be fine with it. Okay, good luck.